Welcome everyone. Andrew Bodden from Farms.com. I'm joined with Todd Heisterkamp from Parker. Todd, tell us a little bit about what Parker is doing right here at the World Pork Expo.
Yeah, thank you very much, Andrew. Great to be talking to you. So we're here talking about our ag filtration solutions. Parker's a very large company. We're in the filtration group, filtration division that handles from agriculture to aerospace. So today we're showing Parker technology and what makes us a little bit different than any other filtration company out there, showing our V-Bank filter that fits into most hog barns and poultry for that matter. As we say, the filter does not care what animal's on the other side of it. So we're looking to filter out viruses, particularly PRRS with the pig environment.
Okay, so what makes your Parker filtration system unique and better than what we see out there?
Yeah, great question. So we do some interesting things with some intellectual property that we have in the media or the fabric that the filter is made out of, as well as we have some engineering properties in our manufacturing process that allows us to have very, very consistent pleats or folds in the media that just really at the end of the day just helps give us a better airflow and very excellent dust holding capacity. So we're capturing the dust out of the air that the virus is riding on.
Yeah, so obviously airflow is a real big important part of this. How do you manage that, and how do you make sure that gets all the way through and we're not really blocking anything?
Yeah, that's a great question. So one of the things that we get a lot when we're talking about is, hey, we're creating a restriction on the ventilation system in the house. So we don't want to have too high a static pressure, obviously slowing air down and creating maintenance problems with fans. So we engineer the right solution based on the required CFMs as well as the desired static pressure. So we're engineering a filtration solution that actually fits in with the rest of the ventilation system. And that all becomes part of the greater biosecurity to keep the virus out of the house. So we say it doesn't do you any good to stick a filter on the barn if the house, you don't have a biosecurity program to support it.
Makes a lot of sense. So can you kind of walk us through on how this system works and how it continues to do that great filtration without losing that airflow?
What we're here doing is showing our test unit. What this test unit does is just shows how the performance of our filters work with what we were just talking about with CFMs and the number of CFMs we're getting through each filter, as well as dust particle capture. So this is Perry Hartmann. Perry is our business development manager, been with Parker and has over 15 years of experience in filtration. So he's really the guy that I rely on and a lot of the team rely on because he has a lot of experience and a lot of knowledge based on it. So Perry, go ahead and kind of talk a little bit about what we're doing here.
Yeah, so in filtration, it's very important that you have the correct number of filters for the airflow of the barn. So with a test chamber like this, we're able to test the filters in a location like Iowa to give us the proper airflow so we can divide that number by the filter needs that we have on the site. We also can do particle capture with this machine, and that machine here tells us what's out in the environment, what is our battle, what are we fighting, how much dust is in the area, is it Arizona or is it Iowa, is it Saudi Arabia, is it California? They all have different environments, they all require different filters and different avenues of way of filtration.
So Perry, let's go ahead and let's talk a little bit about the results that we're showing with the testing that we've done. So first, let's talk about CFMs.
Yeah, CFMs are very important into the hog industry and as well as poultry, is getting the airflow correct so that the BTUs aren't building up too high in the barns. So we coordinate main filters and the pre-filters with the CFMs at the static pressures that these farms are achieving, and matching that with the fans and their performance charts so they're not overwhelming the fans or we're not shortening the life of the filters by having too many.
What we're showing is airflow based on the static pressures, a variety of static pressures to get that desired airflow. So whether your barn's running at 0.2 or 0.15, you know, we can design the system based on that and show that's what we're getting, the right amount of CFMs at those static pressures. Then, as Perry was talking about with the particle counter, we take a test upstream, or the dirty air that's before the filter, and then we test here after the filter, and so we're seeing what actual efficiency we're getting out of that. So we're pulling thousands of particulates that are in the air here, and we're knocking that down and capturing over 95% in a MERV 15, which is pretty typical in a hog barn. We're using a MERV 15. So one of the things is that as the filter becomes dirtier, it gets more efficient. So in time, the filter will be up over 99% of efficiency. So we're capturing 99% of the particulates out in the environment before it gets into the barn. And again, that's where that virus is running on. It's so small you can't see it. Nobody can see it, but we know that we're capturing 99% of the viruses that are out there.
As that efficiency rises, our airflow lowers. So it's when to know when to change those filters out, and finding that sweet spot where you're not throwing away a good filter or you're not overextending the life of the filter.
Yeah, excellent. So that's kind of it in a nutshell. Of course, there's a lot more information that we can be sharing, a lot more data, so feel free to reach out for us.